Yes.
Then you are on the same team. Is it a company in Fukuoka?
No, it's in Tokyo.
In Tokyo. Ah, it sounds really interesting.
Okay. Yeah, brilliant. Awesome. Works, everything works. So everyone on the stream, welcome to tonight's Hack Fukuoka. I'm not going to do a long introduction today because it's Golden Week and we're just a few people here today. But we do have a fantastic talk about Nix and reproducible builds and environments, which is something I know nothing about. So I'm really excited to hear this talk. So I'm going to pass it straight over to David for today's talk. But yeah, if you have questions on the stream, please ask questions there, and we'll be doing this all live today. Take it away, thank you.
Cool. Hello, everybody. I'm David. First of all, the slides and samples in this talk, you can find them on this GitHub repo that are over here. And so feel free to just go there and bash me. There's my Twitter account if you want to follow me, but I guess most people here already are in some way or another following me. So let's just start. So first of all, I'm going to start booting an EC2 instance. I'm going to try to do this really quickly over here. I'm going to boot an Ubuntu one. I'm going to name it Tiny. And I'm going to make it to be a small one, just to make sure don't run into troubles. Because when you go live, you always run into troubles. I'm going to make sure that it uses, yeah, this looks good. Disable. I'm going to edit here and make it public. So it gets public. And with that's going on, let's just start here. So I'm going to start by talking about the problem. Sorry for that. Most people here already sort of knew about the problem because they were in that lightning talk that I gave before. So this is really embarrassing, but it's the same thing that I explained before. Essentially, there's this reproducibility problem. And the reproducibility problem is I should be able to give you the same data, the same code, and the same tools, and you should be able to achieve the same results. That applies to science. That applies to software engineering as well, where your results are an artifact, perhaps a binary, or perhaps is a database table. As much as it is in science, where maybe you achieve p-value or you achieve, your results are whether your hypotheses were correct or not. So my point here being that reproducibility sits at the core of software engineering because we always want that the same code leads to the same artifact. And we want running the same artifact in the same environment. This is what Kubernetes is really good at. You build a container and you run it 1,000 times and you expect to behave the same. If you take it to the world of machine learning, what you have is, aside from code, you have some data. So you want the same data and the same code to achieve the same results. You want the same transformations in model training and in model serving. And that is a big challenge in machine learning, aside from building more sophisticated models. So my main point for this talk is that reproducibility is really, really hard. It's hard to come up with exactly the same results. And usually the symptoms of reproducibility issues, when you have problems with reproducibility, it manifests themselves into, it is your first week in your new job, and then you spend your first week setting up your local environment, and people tell you, well, you need to set it up this way, in this manner. You need to put these cables here, you need to install this, put this environment variable there, and it's just really hard. And usually ends up with case number 2, which is it works in my machine. I don't know why it doesn't work in yours, which is really annoying. Another case that I usually run into is that I use an open source project, which I use maybe for a tiny tool in one of my projects, and I find a bug and I want to fix it, but setting up the local environments to make that tiny contribution just takes a few hours, and I find myself, no, I'd rather not make that PR because then I need to make CI run, and then making CI run fix the bugs, fix the linter, and I'm like, I don't want to install all of that, I'd rather let that go. The other problem is disparate environment fighting. And so what the disparate environments means is that you have different moving parts. So you have the local environment, development environments, which is the environments that you use to code. You have the production environment, that is a container image, for example, and you have the CI environment. And all of that are moving pieces. You need to make all of these agree in some way or another. And the symptom here is you update a version of some library, and now you have to make changes to these three environments. For example, you updated your Python version in your Docker file, but now you haven't updated it in your CI because the GitHub action has a different place where you pin that image, and now you have to go there and fix it. So you need to keep all of these three moving parts together. And that is really hard when a project gets much more bigger and in those mono repos that we all hate and dislike. The case number 5 is you install a global dependency, for example, via brew install or apt-get install, and it fixed your problem of the moment, but later you find out that you broke something else. In the worst case, you end up breaking your entire system, which is pretty annoying. And the case number 6 is you have multiple versions of X in different projects. So let's say project number 1 uses Golang version 1, project 2 uses Golang version 2. And so you work in a project for 1 week, install a bunch of new things. Then the next week you go into work into a bug of project number 2, and then your development environment is broken because it's a different tool set. This is pretty annoying. So the current solutions are language-specific environment toolings. So the promise is you have isolated environments. That's what they promise. So in Python, you have conda, pyenv, or pipx. You have a ton of them. In JavaScript, I'm not a JavaScript guy, but I researched this, and it says that npm CI is one of them. And so the problem is that these tools have a limited scope. I think they started with good intentions, but the problem is way more complex than what they initially thought it was going to be. So in the Python case, there are many C-level libraries. So how do you install a C-level library isolated from the rest of your system? So some tools try to address that problem, but I think they fall short because they underestimate the problem that is lying underneath. So just to give you a slide that I always show when I'm working in a team that uses Python and I join the team, or I have somebody new joining, they usually ask me, oh, what environment tool should I use? And then I show them this slide, which is a matrix of all the environment tooling for Python. Over here you have the tools, so each of those yellow blocks is a different tool, and these blue blocks is a different feature. So for example, one of those features is if it supports non-Python package installation, that means C-level, if they are able to handle that. And so you show somebody this matrix, and then according to the problem, they might pick one tool over another. I find myself sharing this slide more often than I thought I would be. Now you're thinking, oh, David, but we have container images, Docker images. Doesn't this solve that problem? And I think you have one point. I think container images are a pure love. I quite like them. But the Docker files, I think the Docker files are a source of frustrations, really. I think it's just horrifying. So Docker files, what's wrong with Docker files is like, oh, you have John, the machine learning engineer. He worked on an MVP 1 year ago. You know, those MVPs of, grab some data, build some Python model, and then verify if that idea works or not. And then the project has a Docker file. It should be runnable, right? Maybe John even left the company, or maybe he's now working on something else. Well, this is John's Docker file. It looks pretty simple. You look like this should work again. But then, first of all, it starts from Ubuntu latest when Docker build was run. Then it is full of apt-get update, apt-get install, and this won't compile. Maybe it will fetch packages from our repository. The package can disappear. There's no explicit versions of the package, and the side effects are obvious. It's different on every run. Can you pin it to a specific version? Yes, but you need to do some extra work that I'm not going to show in this slide. And finally, the binary that it assumes that Fukuoka package installs a binary called Fukuoka, but it can be in a different path. It can change because this Docker file doesn't really know anything about the Fukuoka package over here. So these Docker files are kind of imperative. We're telling step by steps what happens. And the truth is probably 1 year later, this John's Docker file won't work because I've found myself in this situation at work more often than none. Company went into an acquisition and then everybody left. 1 year later, you're trying to do a security update patch. And then you are like, oops, we cannot rebuild that Docker file from 1 year ago. Well, good luck. So I came here for Nix, now you're telling me, show me what's in here. So think of Nix as a potential solutions to the issues I just mentioned. So at least the ones I consider important for me is that when a new member joins my team, I want that person to be productive from day one. And the number 2 is no breaking environments due to different versions. So just for different projects, I run these like multiple Python projects, multiple Golang projects, all of them with different versions. And every time I work on one and then I return to the previous one, it's just my environment is broken. I hate that. And the third one is one that I fancy, but not one that I think is realistic. And it's essentially, if you change jobs, you get a new laptop, you just run Nix and you get everything set up. So I think this is more of a dream, but you'll see that some people are getting there. I'm particularly not interested in that one because sadly I don't have that much free time. But if I had, I would be doing that. So first start with the Nix confusion. So Nix is a very confusing word because it can refer to 3 things. It can refer to the Nix OS, it can refer to the Nix package manager, and it can refer to the Nix language. So the Nix OS, what it is, it's an OS distribution. Think of it of another flavor of Ubuntu. It's not Ubuntu, but just think of it like another flavor of these Linux distributions. The main difference with that distribution is that it has the Nix package manager. And the package manager is the main focus of this talk. And then there is the Nix language, which is quote unquote a programming language, and it tells Nix how to build packages. So let's start with the Nix package manager. So the Nix package manager is just a binary. You can install it wherever. I'm not sure if on Windows, but at least on Unix systems and on OS X, you can install it. And it's essentially a replacement for brew or apt-get. It can do more things, but this is how I want to get you hooked into this. You can't just stop using brew or apt-get and use this. So you can use this package manager to install a package that is available in Nix packages, or you can build your own package. And your own package can mean anything, from a container to a binary to whatever you think of. A package, it could be a data set for data science, maybe for image processing, video processing, whatever you think of that. So I'm gonna start here with a quick demo. Hopefully nothing's gonna fail, but I'm gonna try to use some of the basic commands of the Nix package manager. So essentially, if you run Nix build, it's gonna, let me just make this bigger over here. Is that big enough? I think it is. So this command is gonna build a package called hello, which is a binary available, a project that is like, it just prints hello to the screen, and it's like a C package. So if I do this, Nix is gonna go, it knows all the dependencies that it needs, and it's gonna rebuild this from scratch, grabbing all the dependencies that it needs on the way. Before I started this talk, I completely nuked my Nix environment, so it doesn't have anything. So it's gonna start from the very scratch, downloading things. I'm just gonna check here that I'm in the correct network, so it won't take a long time. But essentially, it's starting to rebuild everything. Probably it's gonna fetch the dependencies of C, of the compiler in C for OS X, and then it's gonna build it. This is embarrassing because it's taking way longer than I expected. But essentially, if you do Nix build, then you tell it a package name, it's just gonna build it. And it's gonna give you a result file. So if I do here result, lslh result, it's gonna show me that it's a symlink to this path over here. And this path here is a path to the Nix Store. The Nix Store is what Nix is gonna store all the packages, all the things that you built is gonna be stored over there. and it's always Nix/store/a hash. And in this case, this is the result of building this. I can check what it is there. So if I check, there is a folder which has a bin folder in it, and then it has a bin, and then it has a hello app over there. If I run this, then it says hello world. So essentially, it just grabbed all the dependencies, the code, and built it. And that's what Nix build command gives us. You can also just run a package without building it. Like, it builds it on the background, but then you can run it. So there is this common program called causes, and essentially draws an ASCII cowboy saying something, or a horse. And then what this command will do is it's going to grab this package, and then it's going to build it, and then it's going to run it with this text that I pass over here. The reason why it was so fast is because probably I run this before the talk, so it was just an artifact that was compiled already, so I didn't have to do anything at all. The other thing that is really useful is, and I showed this in my previous lightning talk, is that you can create this sealed environment. So you can create a shell that only has a particular Go version or Python version, and it has nothing else. So for example, you can create a shell that only has Go 1.18. This is what I'm gonna do there. It's gonna take a while because I dumped my previous Nix Store. But the next time I run this command, it's gonna be really fast because all of these artifacts over here are gonna be in my Nix Store. So in that case, I'm gonna have a shell that only has Go 1.18 over there. Hopefully that's gonna finish running. But in the meantime, I'm gonna start this other one just to gain some time. This command was gonna give you is a pure shell that has Python 3.10, the AWS CLI command, and Python 3 packages NumPy. So it's gonna have a Python 3 that has NumPy, the AWS CLI, and nothing else in it. And so if now this command stopped running, I think because probably I installed Python before. So if I go here and do Python, it's gonna run, and if I do import numpy, it's gonna be there because I passed it. Oh, well, since my computer is uber slow, what am I running? I don't know. Well, there you go, numpy got imported. And if I do the here which Python, well, which is not installed to start with because it's completely sealed, but I can do this, just add which package over here, and now I can do which Python, and it points to somewhere in my Nix Store. And essentially, every Python version with a specific package will get its own place in the Nix Store. So that in that way, if I have a Python 3 that has numpy and request, it's gonna have its own hash path, so it's not gonna conflict with anything else that I have on my system. And through these hashes is that Nix is able to guarantee that everything is independent, because if the inputs are different, a different hash will be generated. So here underneath I have a shell which only have Go, presumably. So I can do which Go. It says, I forgot install which. But then if I do which Go, it should be there. And if I do Go version, it's going to tell me it's Go 18. Or was it the one that I installed? Oh, forgot how to, yeah, Go 18. There you go. So you have this, so you can build a package, you can run a package, and you can have these isolated environments with these shells. Another thing that you can do with the Nix package manager is to install something in your entire system. Let's say it's not installing in your entire system, but it's just making it available in any path that you are. So this will be the equivalent of brew install, let's say. If I do this, Nix profile install cause, then this command cause is going to be available in my entire system. So if I say which cause is going to live on this Nix profile, but if I do ls alh, it's going to show me that it points to my Nix store. So that is, let's say, the basic commands for this Nix package manager. Let's go into the next thing. It's going to be, yeah. So I want to show you a little project demo that I created. So this is Nix sample. So this is a tiny project. This is just a dummy Go application. And it has something that is called a flake Nix inside. And that flake Nix defines many things. So it's an arbitrary project. It's not unlike the previous things that I run. It's not a package that somebody built, but it's just my own project. If I run Nix run on this, please note that I didn't clone anything. I'm just giving it the GitHub path. It's gonna build this project that I give it and then run it. So this is the project that I have. It only prints some text that is blue, and then that's it. I can also build it. So if I build it, it should be here on results. So if I do result, probably it's gonna, it's a folder. So if I do, let me just do result, and if I do LISH, then there is this binary over there. And if I run it, is this yay, hello world, blue other bar. If I do Nix develop, so if somebody wants to use my project, they don't need to know the details. They just do Nix run my GitHub repo. If they want to build it, they just do Nix build my GitHub repo. And if they want to have all the development environment that I use to compile it, to run tests, to run linters, to run the Golang formatter, then they can run this command, Nix develop. And because my project defines a shell that has everything that you need just to install, just to start developing on it, then if I do this, it's gonna, again, bring all the dependencies that it needs, build them or fetch them from somewhere, and then eventually give me an environment with all of them. In this case, because this is a Golang project, it has the language server, so the LSP language server, so that my Emacs can connect there and it can give me compile errors. But it also has the Golang linter, which is a tool that searches for errors, common errors that people make on Golang. And so those are the two tools that I arbitrarily put there. You can put whatever you want. I guess some people might put BIM or whatever other things that they want, but I just put them over there. And then this one, it also has a Docker file, so I can ask Nix to build the Docker file for me, the container image for me. But before we go there, I would like to just show you, I'd like to just go to the, I'd like to just come here to the instance that I just created in AWS. And I want to show you that I'm not lying, essentially. So this is like a fresh new instance. So if I should do this, this should work. I got no idea why my computer is so slow. Could be because of this. Because it's compiling, maybe.
Is that space messing you up? I don't know. In the SSH after the at.
Could be, right? Yeah. Sorry, it's so big I can't tell. That was a good catch. Cool. Cool, now I'm in this instance. I'm gonna install Nix OS. So in the repo that I shared for this presentation, I have some README with the commands that I've been running. And I have the commands for installing this in this instance. So the installing instructions are over here. And essentially, these are the installation instructions. If I just run this, it's gonna install Nix over here. How much time do I have? Okay, it seems this, I'll be able to do everything that I want to do. So essentially, this is just installing Nix on that tiny instance that I created. And I'm gonna build this project over there. Maybe I'm gonna run this at the beginning. Oh, first I have to do one little thing. This is the only thing you need to do when you first install Nix. Aside from running that instructions, which is a single line command, is that you need to create one folder and yeah, just enter, I agree with that. This is just creating a folder, which is the Nix, some basic Nix configuration. And I'm gonna create a file over there and I'm gonna add this line. This is the only thing that you really have to do And then if you do, cool. And then because I want to build that Docker image, I'm going to install Docker, but I'm going to install Docker using the Nix package manager. So if I do Docker, you'll see that this doesn't have any Docker, right? So I'm going to, oh, maybe I need to restart. Maybe let me just check. Okay, command Nix not found. Will install. That's not good. It's not what I was expecting. I'm going to do this just to double check. Maybe that session needs to be updated. Oh no, that's why you shouldn't do live stuff.
We're excited.
Okay, there it is. I just needed to restart the session so that it picks up. So it's gonna install Docker over there. So just the Docker, what is it? Just the Docker binary, I guess. So while that is running, I just want to show you that this project that I built has the developer environment where people will do their stuff. It can be built by somebody without knowing anything about how it lives inside. And finally, you can also build a Docker file. Sorry, the container image. Just to be clear, there's no Docker file in my project. If I go here to David and then Nix sample, you won't see any Docker file here. In fact, I'm gonna go into this later, but there is a place in this Nix language thing where I'm defining a Docker file, kind of like a container image, not a Docker file. And this is what this is gonna use to build that. So I'm gonna run this command. Essentially what this is saying is, build from this project, this artifact that I call Docker. I could have called it whatever name I wanted. I'm gonna run this, and then this is gonna fetch whatever it needs to build that project, whatever it needs to build a Docker image, and then it's gonna output it, just in a place just like I showed before. In that result, whenever you run Nix build, it's gonna generate this .result sort of like artifact that you can see over there. So, well, since this will take some time, maybe I can move into something else. Well, I guess this is what you want to know. How does this work next? Maybe we can go with that while this is doing. I thought this is gonna be much faster, but maybe not. So the question is, how does this all work? And how does this all work? And the thing is, like, let me just check a few things. Where's it there? Okay. So the question is, how does this work? And essentially what the Nix builder package manager does, it transforms some Nix language instructions into something called a derivation. And a derivation is, so this Nix language instructions is just that file that you saw with Nix stuff. And the builder transformed this into a derivation, which is an agnostic representation of how to build something. It's like this language agnostic thing that it just tells you, here are all my inputs and here are my expected outputs. The important thing about a derivation is that it can calculate what is the output path in the Nix store. So it can say, oh, these are all my steps that I need to do, and these are all my inputs. And based on those two things, it calculates a hash. And that's the hash that you see on the Nix store. So essentially, you can see how Nix does this derivation. We're going to take a look later. But essentially, there is another step that takes that derivation and executes it. And the output of that execution is what we see in the Nix store, which is an artifact. In this case, has been my binary. In this case, it's my Docker image. So if I do ls/lh result, I should see an image here that points to this file in the Nix store, which is a Docker file. Sorry, it's a container image, sorry. So if I do Docker load and I pass result over there, sorry, I think I need to do sudo here for a specific, didn't that install Docker? Docker, maybe. Well, that's not expected. Let me just try to do, okay, Docker's there. It says it's not running. Maybe there's a demo that I need to start. Nope. Let me just do this again, because maybe it has to do with I install it and it's not in the path or something like that. Let me just do sudo docker load and then result. Well, not as reproducible, I guess. I mean, it has to do with I can run Docker. I'm not so sure why. Maybe I need to run a service. Maybe I need to do something like service ctl start. This is embarrassing. Let me just check if this will work.
Docker run?
No, I think Docker run will just start that Docker image. Okay. Anyway, I think this doesn't matter. Maybe we can try later. But essentially here the result, if you look at it, is a tart file, which is a representation of a Docker image. And then you can do Docker load and load that image into Docker. And then it's going to tell you what's wrong. I mean, we can try that later. That's not a big deal. So essentially, when you do Nix build, is what it takes that derivation and puts it into an artifact on the Nix Store. So what's the magic here is that the magic, I think it's idempotent. So ahead of time, you know where the path of an artifact is going to be. So there are no side effects. Essentially, if you have the same inputs, then you have the same outputs. And you have to be careful with derivations that are not impure. I wanted to show you something with this Docker image. So maybe let's just try it later. Because it's very funny when you generate Docker images with Nix, they always show as they're being created at a particular date. And the reason why they all show this very old date is because given the same inputs, you need to generate the same outputs. If you generate a different date every time, it won't be the exact same output. So this is something funny, but anyway, I don't think it's important for the message that I want to give. So among other things that you have in Nix, you have the Nix REPL, which is some sort of like command line tool where you can use to play with the Nix language. So you can load the Nix packages. You can load Nix packages and play with them a little bit. If you go to the README file of the repo that I prepare, you can see some things that you can do. So for example, you can look at the docs of built-in functions. So this might be really useful if you're trying to do something. You can actually look at derivations. So in this case, I could just import Python 3 and say, out of all the possible Python 3's packages, I want a Python 3 that has NumPy. And so it gives me here the derivation. Derivation is, remember, this intermediate step that has this agnostic way of representing how to build something. I can also say, well, I just don't want the derivation. I want you to build that artifact. And if I pass this column build, it's going to actually build that derivation. That is a Python 3 with NumPy. And it tells me, well, I actually built it, and it's here in the Nix Store. I'm going to leave this SSH over here. And if I go there and do Python, then I can do import NumPy. So this REPL is really useful to just get used to things, I believe, even though the structure is slightly similar. I can also ask it to build a shell. So if you remember those isolated shells, in this case, I'm asking it to build a shell called sum or whatever name you want. And the packages that I want inside is JQ, this tool for manipulating JSON files. So I can say, I want to build a shell. And then what this does is it gives me a shell that has JQ inside. And it tells me, well, it's living in this path over here and in the Nix Store. So if I go and look at it, it's just a file. And if I do Nix shell, I believe it's Nix shell. Yeah, it's Nix shell. I don't usually, let me just take a look here. I think it's Nix shell. Yeah, I think if I do Nix shell, Let me just take a look. I think I don't usually use it like that, but there is a way to do it. I think I put in one of the examples that I prepare. Yeah, I think you can do result, Nix shell, result. Well, this is just a file that the Nix shell can use to run. I can't remember if it's like this. I think it's like maybe F. Well, here I am trying to do live stuff that is embarrassing. But essentially, when I run these shells that are like, that you showed they had this pure thing, this is how you can actually build them. And then there is a command that you can pass. And it's you can go in there and do things, just like I did. Just like I did with the Nix shell command over there. I'm probably gonna look it up a little bit later. But essentially this REPL is really useful if you just want to play with things and see what happens and see how the derivations get built. So here start with the Nix basics. Essentially, if you go to the repo that I just provided you, there's a few code examples. I would say that this is the simplest example that you can have in Nix. And what it's essentially saying is I want to be able to import any package that is available in the set of official Nix packages. And then there are some default functions. And one of them is this function called run command, where you can just think of it as a bash file where you can make it do a lot of things, run any command that you want. And so what I'm saying is this is a derivation. This is like a build description, which is going to run commands. And the command that I want to run is hello, echo hello. And the output of these derivation, what gets output into that result is going to be this out variable over here. And essentially, a derivation will always generate something into the Nix Store, so you always want to write out to this out variable over there. So if you do here, you do Nix build -f, and then you pass this sample. I think this is sample 1 to Nix, I believe. This is sample.nix. It's going to run that derivation. And so if I look at result, it's going to have the hello that I just echo over here. And if I look at the path in the Nix Store, it gives me this path over here. I'm going to change this to be hello, David. And I'm going to rerun that derivation. And I'm going to look at the path of the result. And you can see that their hash is different because I changed the Nix file. And that means that I changed the instructions of how to build. So what Nix does is gathers all the inputs based on the inputs and the instructions of the build, it generates that hash. And I think this is the most important part of this Nix stuff and why it is always reproducible. Here's my example number 2. It's essentially the same example, but it's just to show you that you can actually create a folder and multiple files out. So if I do Nix build sample 2, what it does is it creates a result that it's a directory that has cat and dog, which is the commands that I just passed over here. And if I change some of these outputs, then the whole hash is going to change. Example number 3, again, just importing the Nix packages over here. And then this time I'm going to do something more interesting. I'm going to use the Python package. And Nix is smart enough to say, hey, in the commands that this build is doing, we are referring to a Python package. So it's going to install it or build it or does what it has to do and then run the rest of the command and put this stuff in output. So if I run, this is the example number 3. If I run sample number 3, it's actually putting Python 2.7 for whatever reason. And if I got to result again, lslh, I do this, and then I do cat, and then it says hello from Python, which is what we had over here. So just think about it, like we just referenced Python, but we didn't tell it exactly, like install Python here and then look for the path there, because the Python package has its own hash in the Nix store, it knows where to find it, and it just replaces this, and it, in a smart way, says, I need to install Python. I don't know exactly what to do, but I need it has to be provided in that space. I'm going to look for example number 4. Well, 3.1. In this one, I'm going to use the Python package, but I'm going to give it another input file, which is a tiny main Python file that I have over here that says hello from file. And if I run that one, I'm going to do, which one's this? 3_1. If I did this, then I'm going to look at the result, right? It has this over here. I can look at the result by doing cat hello from file. If I change this file to hello from file number 2, Nix will rebuild it. And if I look at the result hash, it's not going to be the same one as before. Like I'm looking in my library and I can in the history and I can find it. This is because now Nix says this is one of my inputs. So I have as an input the Python package and I have as an input the main.py. So that's considered an input. If it changes, that means it's a completely different build. I might have to rebuild everything. So this is what it keeps, what makes this idempotent. Example number 4. So this time, this is what I mean with impure derivations. So in this case, every time this derivation runs, it's going to be a different result, right? Because it's actually printing the current time with seconds and everything. So if I run this, Nix is going to build it the first time, and it's going to give me a result. And if I just Nix build again, it's not going to do anything because it says, well, it's the same file that I had before. Nothing has changed. But in reality, we know that this is not correct. The result should have been different, right? It should be a different timestamp. But this is what we should avoid, this kind of like impure side effects when building artifacts. And many of the stuff that we build nowadays have this problem. I'm going to go with the next example. The next example builds a shell. And so this, what it does is important. The Nix packages, and it uses this function that makes a shell, and we can tell it there which packages we want inside. So I just arbitrarily said I want JQ and I want the JDK11, which is Java. And then when the shell starts, I want to echo this message over there. And for this one, you can run it like this. So this gives me a shell which have the JVM, I believe, maybe Java. What is it, the Java commands? I forgot. Java C, maybe? That's a good question, but I'm pretty sure we have JQ. Oh, well, maybe I lied to you. Did I run the correct one? Let me just check. Oh, sorry. Just run the incorrect one by looking at my history. Well, I think that's going to take a while because, as you can see here, it's downloading the JDK, which is not pretty good. But maybe if you trust me, we can go to the next example because I'm running out of time. So the next one is a little bit more complex. In these examples, I have a Golang project. And it's just to have the bare bones, it's just a main.go with printing something. But it has a Go mod. I'm not so sure how familiar you are with Golang, but the Go mod is like, it just makes it a project. And so Nix has these special functions. In the case of Golang, it has a function called build Go module. And build Go module, you'll tell it, here's my source code. Ignore this for the moment. But essentially, if you tell it, here's my source code, it will build a Go project. And it will just generate the binary for it. So I'm going to exit over here. I'm going to quit this. I'm going to quit this. I'm going to go to Nix talk Nix. Yeah, I'm going to go to samples. And I'm going to go to Golang. This is essentially the project, the folder that I was. I'm going to do Nix build. Oh, well, this shell over here finished some. Maybe we have Java. Yeah, we have the Java compiler now. So you can see that you can also programmatically create these shells environments, which is what I wanted to prove. Then you also have Nix build. I'm going to build this sample that we have over here, which is sample1.nix. And then this is essentially building that Go project that I show you, which is just a dummy example, but it could be a much more complex one, of course. So for every language, let's say Python or anything, you get these special functions that already do all the heavy lifting for you. So you don't have to specify, oh, this is how I built a Python package. No, there's a build Python package function over there. So if I look at here now, there's again a result, and the result should be this thing on my Nix Store. And it has a binary, which is this dummy, that prints something, which is what it was supposed to do. And then the next sample builds on top of this one. And what it does is it builds the Go module, saves it in a variable A as a package. And then it builds a shell that has the JDK, JQ, and the package that I built before. So this is saying here in a more advanced example, I would say this is how I built my app, and now I want to use it in a shell environment. In another more complex example, you could say here is how I built my Go app, and here I wanted it to be part of a Docker container image. And then here I'm not saying this block here doesn't know how A gets built. It just knows that it needs to include it. And if something changes with the code, my Golang code, it will reveal the shell and it will reveal my project. And then this is when things become really powerful. So I'm gonna run this example, which is the sample 5_2. And of course, this just builds a shell. And remember that in order to build with the shell, I want to be in the shell. So I need to do, which is that we did here, Nix shell pure, and then we pass the sample_ to Nix. Shell Nix. This is part of the all commands which have that dash. So essentially, if I go here now, here I have the Java. Probably if I do which, I'm not gonna have the which command. But if I should have a package which is A, and I think the name should be dummy. Yeah, dummy it is. So this is when things become really interesting. And so here comes one of my last examples, which is here I'm building a Docker image. This is a bit tricky and I'm kind of telling you a lie, but please go with me because you probably don't realize the lie that I'm telling you. But aside from picking the Nix packages, I'm picking a version of Nix packages that are only for Linux. And the reason that I'm doing this is if I build my binary for Mac and then put in a Docker, the Docker file will say, oh, I don't know how to run that, and it's gonna give me an error. So here I'm saying I want a flavor version of the Nix packages that are for Linux 64, not ARM, which is my laptop. And then I want you to build me a Docker image that has that package inside. There's no difference within this example and the Python example that I gave before. Essentially, I want you to run Python there and print this message. So I'm gonna run that. I'm gonna exit over here. I'm gonna go to Nix build and I'm gonna go to Nix sample. I think that's number 6. And then this should have built me a Docker image. Probably already built it before, that's why nothing happened. Like probably it's already in my Nix store, so if I do lslah, look at results, it's probably different from what I've seen before. I don't claim that I can read hashes, but it looks like it's different. So I'm gonna do Docker load. I'm gonna load this over here. And it says, oh, it's Nix sample, which is I think the name that I give it over here to this Docker image. And if I do Docker ls, Docker image ls, I think is the command to inspect the Docker image. Oh, no, I'm not so good at copy pasting. Then we can see what this Docker image looks like, and look at it, it was created 53 years ago, which is the Unix timestamp, when the Unix timestamp started. So when Nix does this, it sets the timestamp 0, which is 53 years ago. It's pretty interesting. And then you can run it. I can do Docker run, and then, which is this one. And then it puts hello, because the command is this thing that I pass over here. You can put whatever commands there you want and packages. So, which takes me back to after minutes. Yep. Yeah. Cool. Sorry. So going back to my slides, container images with Nix. What is the big thing about this? First of all, they are smaller because Nix knows exactly what we need. So when I ask Nix to put Python there, because it knows how to build Python, it knows all the dependencies and only its dependencies. So you can generate super tiny images. So I have a scratch image with Python in it. This is the smallest you can get. We don't tell, and essentially we don't tell how to build like container images. We describe what packages the container image should have. And then the big takeaway is you can try building this Docker file, this container image 10 years later, and presumably it should do much better than the Docker file I showed you at the beginning. The next thing that I want to show you is to go back to this initial project that I showed you. So this one has something called a flake. And a flake is just, here the examples that I show you like this one is just like an isolated function. That it can work, but it is not how you usually write things. So there's this thing called a flake, and it's like predefined structure for a project that uses Nix, something like that. It's just a standard. It's just use the same things that you showed you before, but you have to put the things in the correct box for it to work. So the Nix Flakes have, the Nix CLI tool has some commands that you can use with this. One of them is Nix Flake show. So if I do Nix Flake show, let me just do this, just to copy and paste this thing. And then I'm gonna do Nix Flake show on my project. It's gonna show me, I'm gonna make this smaller over here. It show me all the artifacts that this generates. So this, it's telling me that this flake generates me some maps for all of these architectures, and that it has an app called Nix sample. That it also has a dev shell for all of these architectures, and that it also has a package called Docker. That's why I did something when I was inside that SSH, that Sunny instance, trying to build that Docker. I did something like Nix build, I did something like this. Nix build, oh, no, let me just steal this. I did something like this, Docker, and then that's gonna build you the Docker image, something like that. Cool. So the structure of these flakes is essentially you have a block for defining your inputs, and your inputs are all the repositories that you might be consuming from. And the outputs, they are predefined. So the default package is what is used when what's gonna be built when you run Nix build. The default app is what is run when you run Nix run. And Nix develop is what it's run, the shell that you get when you run dev shell. So in case of my app, let me just make this bigger. I have a dev shell here that gives me all of these Golang tools. And so this predefined dev shell is telling me, oh, when somebody runs the command Nix develops, and there is this flake.nix inside, it's gonna pop all of these things in that shell that I have over there. So this is only like the same Nix code that I just showed you, but it's essentially just giving you a structure so that people can run predefined commands on them. And this is like the main structure, so I know this is just too small to see, but essentially there is a part with the inputs, which are all the repositories, packages that you are using. Usually it's just the standard Nix packages repository, but you can add your own. Like I can add your flake for machine learning and bring some packages over there. And then there's this part of the outputs where they're pretty much predefined, but you can always extend it to return whatever you want. It's just that, to build whatever you want, it's just that whatever you put in the predefined ones, people can use them via Nix build or Nix develop immediately. And people will be like, oh, if I see a Nix Flakes in a project, I'll just go, and I want to do a contribution, I just go to that project, do Nix develop, get all the tooling that they use for linters and everything, and then start from there. So here's just the default structure. I just try to separate all what you have here to something that is like bare bones. And essentially, there are this part where you put your code, essentially. So far you've been wondering, but you never pinned any versions. How can this be reproducible? Well, that's why flakes are like the last bit of this talk, because when you create a flake, like if you go to my project here, it has something, it should have, hopefully I didn't forget to add it. It's just too big, you can see. So it has this file called flake.log, and it essentially says all of those repositories that you told me in the inputs part, I'm gonna lock the versions here. And that way, when somebody uses this flake, they are sure we are using the same versions of absolutely everything. So there's this thing called flake templates, and it's essentially, it saves you from writing a lot of boilerplate. So this is also here in my README. So if you go here, there's a flake. So there is a flake provided by the Nix team, which is nixos/templates. And it shows you a bunch of templates for project. Because it's a flake, I can do Nix Flake show, and I know. So they have like a base Golang project, a Python project. And if you use this command, Nix Flake init, like I'm gonna run this Nix Flake init for this Go Hello project. I'm gonna do it over here so that I don't pollute my environment over there. But I'm just gonna copy this thing. Okay, there you go. I mean, it's just too big for me to see, but it says it created a bunch of things. So if I look at this folder, which was empty, now I have a flake nix and a main.go. And if I look at the flake.nix, it has the basic structure for building a Go project for all these architectures. So you can create your own templates in your GitHub repo and reference them like this. So some people have their own already, but you can also use other people's like these predefined templates. I guess maybe the machine learning people might have something that they use already, so it saves you work. Coming back here, I'm about to finish, so no worries. So just to recap a little bit, in Flakes, we only define how to build our app once. Then we use that definition to create a local environment and build a container image. So we are not constantly battling with multiple moving pieces. One part of this project that I did it a few weeks ago, and what I was playing with is look at my GitHub CI, look at my tests. I don't install any GitHub actions, which I absolutely dislike. I just have an action that install Nix and then says, create my local shell for developing, and then run this command, go test. This action doesn't know Go versions, it doesn't know linters, it doesn't know anything. And here I have a linter, so it's an action that checks the linter. So it only knows how to lint because I need to give the command, but it doesn't know that the version of GoLint, because that's defined in my flake. It only installed Nix and then says, whatever is the shell development environment, go there and run this. So CI is the same as my local environment, which, oh my God, every time I try to set up this up, it's like, oh, it runs on a GitHub action, and then the GitHub action is just not the same. So annoying. Anyway, this makes you have less moving pieces. So just to recap again, we use Nix in the CI, the dev shell. We use Nix in the local development, dev shell. And any changes to anything, code dependencies generate a new hash. So everything is pinned. So CI equals local dev equals build app and app in container image. Everything is the same. You change one, you change everything. There's no way you can have disparate environments. This is a mixed section. I'm gonna finish.
I was just gonna say for people in the room that there's last orders at the bar if you want to get anything. We can keep going and chatting and do Q&A, but I just wanted to make sure no one wanted to get something so I can tell them to close up. Is everyone all right? Okay, cool. Yeah. Carry on.
So this is just a mixture of things that makes my head explode. Some of them I've played with, some of them I have not, and I'm willing to play with them in the future. But this is like, blow up my head about NixOS. So in NixOS, This is about the operative system. I've not talked about this in this presentation. But in NixOS, if you change your configuration, which in NixOS you can configure everything in the Nix language, the sensitivity of your trackpad, the key bandings, everything. If you want to test your new configuration before applying them, you spawn a new VM, which is like a clone of your system. And then you can run that VM and look at things will go wrong or not. I just think that's absolutely insane because the VM also runs very quickly for reasons I'm not going to go into, but it uses something called micro VMs. I was just blown out by how fast it was and how crazy that is. So you just run this command and you have your system running in a VM. I just thought it was crazy. So when you make in NixOS, this is a different one from before. When you make a change to your system, you can roll it back. When you restart NixOS, when you install multiple operative systems in your computer, when you start, it shows you like, oh, do you want to use Ubuntu or do you want to use Windows? When you start NixOS, it tells you like, oh, I have these versions of your system. Which one do you want to use? And it tells you the hash of it, which I just think is pretty cool. And why is it so cheap? Because a new system is just something new in the Nix Store. That's it. You remove or add something to the Nix Store. The next thing is this Nix Darwin. I haven't played with it, but it essentially lets you manage your Mac as it was in NixOS. So you can describe everything, your apps, packages, the sensibility of your trackpad, screen resolutions, key binding, services, everything. So some people have their Nix files and then they just rebuild their entire system from it. So you got a new laptop, just run this. And then boom, kaboom, it's all gone, ready to go. The next one, I think this one broke my brain as well because essentially Nix has the NixOS system. They have integration tests. And how they do it is with this micro VM stuff. So every package that you see in the Nix package repository, they have integration tests. And the reason how they do it is these PAM VMs. So they build their package inside a VM. Why they can do it? Because they can trace back everything from a package. So if my package depends on the C compiler, they can bring the C compiler. If the C compiler is not built, they can build the C compiler. They can go back to the beginning of time. It's just absolutely insane. So if the build is successful, then the test passes. And this is super lightweight. This is not like it takes a long time. I just think this is crazy. And the most important thing for me is that it's very compact because all your test is in a single Nix language file. And I saw a test that had like a database. So it was like a Postgres test. And it was like, they spawn a VM with Postgres, build whatever they have to build, and then they spawn another VM and make the second VM make a request to the first one. And if all of that happens, then the build passes. I thought that was just very simple compared to having these Docker compose files that they have their problems. So anyway, this is another different one. It goes explode. And this is like, you can ask Nix to build your artifact remotely. What? Yes, for any architecture. So what that means is that if I'm on an ARM machine like this one, I can build for other architecture if I just have a setup machine somewhere. I could say like, and I don't have to do anything. It will be the exact same Nix build command. It's just, I just have to add a config file that says, you can use this machine, you can SSH to this machine that has Nix. And if it detects it is x86, then it will say, oh, I need to build this 86 thing, but I can't do it here. I'm going to do it over there and then get the artifacts here. I just think that's insane. And this one is just beauty. The copy command. Guys, you have not seen, look, if I run this, Nix packages Apache Kafka, it's gonna copy to this, my remote host, everything required for Apache Kafka to run if the host has Nix installed. Why? Because, so this is assuming that I build Apache Kafka locally and I want to deploy it somewhere else. If I just put Nix there, I can copy what I built locally and just put it there. Why? Because Nix knows everything that depends on the Nix Store. So it will say, oh, if I copy just all of these artifacts that are in the Nix Store, and because I have this dependency graph, then you can just copy Kafka over there. So no container, no Kubernetes complexity stuff. I'm not saying that this is not complex, but I just think this is a beautiful side effect of having all these dependency mapped. So this is because Nix packages know their dependency. So the future, this is the next part. So the hype train, I think Nix has taken off in popularity. I tried to use this years ago and it was just so difficult. Now it's much easier. Now I think what's happening is that very clever people are improving the developer experiences by creating abstractions on the top. So these are tools that abstract the complexities of Nix. So one of them is dependencies, and this is essentially a layer on top of Nix that abstracts some complexities, because that Nix language there is not the easiest thing, let's be honest. And it adds some things, like it lets you run services. So you can say, hey, I want this Nix shell, and when it goes up, I want to run Kafka, or I want to run a database. Something similar to Docker Compose. And I think this is good because you can change the level. If you want to go really deep down, you can plug Nix language again. But if you want to be abstracted, you can just go for that higher level. The other one is this one. This one is like Python's virtual environment, but using Nix under the hood, so it's more powerful. This is not Python. It just looks like a Python tool. And essentially, it's like this flux. And you can say, I want an environment whose name is demo, and I want to install the hello package. So it looks much easier than that Nix build command. Well, my final thoughts, 10 minutes late. So is this tech ready for the spotlight? In my opinion, yes. This is something that can make my team more productive, yes. But it is, from my opinion, it is worth waiting for the tooling that is being built on top, maybe. Should you give it a try? I think you should. So this is the Michel Hashimoto, the guy who built Terraform, and he has been using Nix for a while. In fact, he has a Mac computer, but he develops by having this VM of Nix OS, and he spams his VM from scratch, do his develop work, which I think it seems he already does. But then for some apps, I guess he still uses Mac OS. And then he's just very bullish on this. Like he wrote this some end of April, some days ago. And I thought it was crazy because I also feel it's really powerful. It gives you this Nix God complex, which is called. The next one is this Toby Lutke, which is the guy, founder of Shopify, I believe. And he mentioned this at the end of last year, that is one of those techs that is worth taking a look at, even though the learning curve is a little bit high. So this is a repeated slide. And then these are some recommended sources that I used to build this presentation. I think there are much more sources nowadays, but these are, I would say, very essential and good ones. And you can go to the repository where I have all of the examples that I ran today. Yeah, that's it. That's it, guys.
Thank you so much. That was a fantastic talk. It definitely piqued my interest in Nix. Any questions we've got? I thought we might do a couple of quick questions and just check questions from the stream, and then turn the stream off and then just have a mess around with some more stuff. Any questions?
So it's pretty obvious to see how Nix is useful for developers, like distributing development environment. So far, are you only using it for developers or also for any users, or not for end users?
I think so far it's only for developers. Yeah.
Okay. That's what I thought. I just want to make sure I understood. Thanks.
I mean, just to add to that question, maybe, like, do you see it replacing Brew? Because Brew is kind of sort of between end users and developers sometimes. No?
I think it definitely will. I think it definitely brews in risk, because I'm not sure if you have run Brew installed recently. It takes a long time. It tries to update so many things. I ran Brew by mistake just because of memory. Like it's on my memory, I Brew installed something, and it broke me a bunch of stuff, and I was like, Why did I do this? So I think definitely it's in trouble. Maybe they'll build something on top of Nix, why not? But Nix still has its issues, like when you want to specify the version of something, it can get a little bit tricky. It's not straightforward sometimes.
Yeah, I noticed before you installed Python 2.7 for some reason. Why was it 2.7 in that situation?
Why was it Python 2.7? I think it depends on the Nix packages version that, like, if you see that in the Nix flake.log file, there's gonna be the git hash of the Nix packages, and that's where the Python version is defined. But I think Python package by default is Python 2, and then there is a package called Python 3. So I think that's probably the reason in this case.
Fair enough. Thanks. Any other questions?
So in my case, I use USB devices or the UI for showing images or something like that. Like, is it possible to do it with Nix, or like do you have to, for example, build a Docker and like build the Nix and then the Docker and then use the Docker? Like, is it possible to? It's only command, or is it also possible like USB devices or like a UI?
Sorry, what do you mean with USB devices?
GUI.
Like camera, for example. I want to connect a camera, for example, or like for example in Docker I need to pass when I get Docker run, like I have to pass the USB camera, for example, like. But anyway, like for example the UI, in the case of the UI, like is it possible or?
I got no idea. I think it should be possible. Like if this has to be with running the Docker, or it's a build time.
So like I mean like if I have the Docker, I can buy the Docker. But is it possible to do it only in Nix, or would I have to do it? Would I have to build the Docker and to use the Docker normally? There is no like in Nix OS to use a UI, for example, or?
I don't think it is. Yeah, I don't think there is such a thing. Maybe you can build one.
Okay, thank you.
Cool. Any other questions?
How many different devices are you running Nix on?
Nix OS.
Any like either the OS or the package manager? Like how many different devices have you put it onto?
I put it in everything that I work. In my working machine, I have in my laptop for work, I have it over there, the package manager. In this, which is my personal laptop, and I have like a small Raspberry Pi where I have Nix OS, and I was trying to look at how would I deploy like an app, like a like kind of like Kubernetes, but instead of sending a container, I'll just have like build my Golang binary, and then how would I ship it to it? That's what I was trying to do, but it's very early days for that, maybe. Yeah.
Was it lightweight enough to run on the Pi?
Yes. It's very lightweight.
Nice.
Yeah. But it's very difficult. So one of the things is that you don't have like a booter, if that makes sense. Like you cannot download an ICO and then it runs. You need to write a Nix file to be able to boot it for the first time. So it's still very annoying.
You were running it like on bare metal without an OS on the Pi. Is that what you're saying?
Yes.
Okay.
Yeah, something like that. So you need to write your own Nix first configuration, and then you need to build it, like Nix build that, and then you deploy that into the Raspberry Pi. It's not that easy, so I think the Nix OS will take some time to take off, maybe.
Well, I think that's all our questions. I'm going to shut off the stream, but we're going to hang around and keep chatting. So thanks again for your fantastic talk.